If you want a proper Kivy installation for Android Python to build stable, crash-free applications, then this video may be for you. I made this video because I feel that the official instructions for Kivy Buildozer installation are not super clear on some essential steps for a solid build environment. Without these additional steps, the app that you build under Kivy Android can crash frequently even though your Kivy and Buildozer are installed normally. And you can find yourself spending too much time troubleshooting these crashes, whereas you really should be focusing more on what matters the most, designing and developing your app. I have a Ubuntu 24.04 LTS desktop Linux machine here running under Oracle VirtualBox version 7.0.18. I chose Linux because that is one of the operating systems that allows compiling for Android as per official documentation. I've brought up a terminal in my Linux virtual machine. Python is usually installed as part of the Ubuntu Linux installation. Let's check the installed Python version. Version 3.12.3 was installed on mine. We need the Python 3.12 package installer, so let's install that first. Next, we're going to install a Python virtual environment. If there is one way to fix all kinds of startup problems, hard to debug crashes or compile issues for your Android APK under Kivy Buildozer, it is the installation of Kivy inside a Python virtual environment. The official Kivy installation instruction page merely says it is optional but strongly recommended to use a virtual environment. But I find that we must use a virtual environment. It is not optional if you hope to build stable Android Python apps in Buildozer Kivy. And the reason for this is explained on the Python documentation page here. Applications will sometimes need a specific version of a library because the application may require that a particular bug has been fixed, or the application may be written using an obsolete version of the library's interface. This means it may not be possible for one Python installation to meet the requirements of every application. The solution for this problem is to create a virtual environment, a self-contained directory tree that contains a Python installation for a particular version of Python plus a number of additional packages. Let's create a directory myapp for Kivy. For now, I'll give read-write execute permissions to anyone accessing it so that we will not face permissions issues while installing the Python packages and modules for Kivy. Let's change to this directory and launch the virtual environment. Sorry, we need to create the virtual environment first. The virtual environment is now created. Let's activate it. We're now within the Python virtual environment. From here, we will now install Buildozer for Kivy. Okay, we need to also give Buildozer adequate permissions of .venv directory, the base location of our virtual environment configuration. Let's retry Buildozer install. Okay, the Buildozer install has completed successfully. This time it completed without any permission error. Next, we will use the Debian Linux Advanced Package Tool, or APT, to update our packages and their versions from the system or distributions repositories. We want everything updated to a nice baseline of package versions that we expect to work together. We will now install a list of packages or modules needed by Kivy. I'm going to copy and paste the entire command from this page here. Likewise for Python, I'll stick to the version recommended on the Kivy install page. We need to omit the user flag since we are installing Cython in our Python virtual environment. Let's retry. Cython is now created. If you want a separate video on installing a specific Cython version, link is in the description. Let's configure our config file for bash environment with the path environment variable as instructed here. Next, we will install the automake utility. In Kivy's instructions, automake install is only suggested for iOS build. However, I find I needed to install it for Linux too from trial and error. For the next set of package installs, we need to change the system repository from which apt will download the packages. But before that, it is super important to know the implications of doing so. Here on this website, it says, being able to change the repositories used by your package management system is a powerful feature, but this power comes with some responsibility. Users are cautioned that it is possible to break your system in a way that it could be difficult or impossible to cleanly fix by adding third-party repositories or repositories for a Debian version that does not match your current version. These repositories create risk of conflicting package versions, creating what's sometimes called a Franken-Debian system. The whole concept behind a Debian stable release is that the Debian developers have picked a set of software and their versions that function nicely together. While this software is patched to fix security issues, the software is frequently not the latest version. It takes some experience to know how the repos may be changed without the risk of breaking your system. Users of all levels are advised to change repos cautiously. Therefore, if you change your repository for your specific package install within your Python virtual environment, install the required packages and then remove the repository change immediately afterwards. To change the repository, we need to add a line to the sources.list file like so. Let's do an apt update. Next, we will install terminfo library, which is libtinfo5. Again, I found the need to install this package after trial and error. Here's some info on libtinfo5 on your screen. The command has completed. On mine, libtinfo5 was already installed during my mini tests. Next, we will install setup tools. Again, I couldn't find a step requiring installation of setup tools on this page. However, if you dig further, it is mentioned here. Finally, we can initialize Buildozer like so. We can see that Buildozer spec is successfully created, which is an indication that Kivy for Android Python has been installed. I've tested my Android APK, which I built on my Kivy Buildozer, and it works perfectly. If you want a walkthrough of the code and testing for this Android application, check out this video.